The leverage macro contracts are meant to enable leverage by having contracts that will take on the debt, and they basically will open the CDP to themselves and then sweep the tokens to the caller. And in order to take leverage, they're going to use flash loans. The system has a bunch of contracts, but at the, to make a long story short, you're going to have the reference contract, which is meant to be deployed as a standalone contract. You're going to have the delegate target, which is meant to be delegated into by the diamond-like, and then you're going to have a factory, which is just there to deploy the reference. And lastly, you're going to have the leverage macro base, which contains the majority of the logic. So the main difference between the macro reference and the delegate target is the implementation of owner. The delegate target expects the contract to be a ownable like contract, and so it's just going to call owner onto itself, and that's why you can delegate use this as a delegate target, because the owner is not hard coded. Whereas in the reference version, the owner is just an immutable variable. We call it the owner, and then we override the owner function, and that basically is how we allow this to work. We also have a reset approval to avoid any form of griefing. But as you can see, there's very little logic in these implementations, whereas in the base contract, you'll see there's a lot more. We have all of our pointers to all of our addresses. We also have a setter for sweeping. You wouldn't want to sweep on the diamond-like because the diamond-like is a smart contract wallet, so you can always sweep later. Whereas you will want to always sweep if you're using the reference version because the reference will just take on the debt, but you probably want the tokens for yourself. That said, as you can see, we have different type of flash loans. You can do no flash loan. You can have a flash loan of eBTC, a flash loan of stETH. We're going to have a specific type of checks after an operation. And you even have operators that you can specify as a way to effectively run checks on any balance, whether you want to have a balance that is equal to, greater than equal, or less than equal. And this is all done through this check and value type struct, which can be listed for the post-check param. So there's a fairly high level of abstraction in order to allow all of these checks and to make them generic. So this is gets complex very quickly, but if you run it for an example, it should be a little easier. That said, the entry point for the contract is do operation, where again you specify what you want to flash loan, what you want to borrow, what type of operation you want to perform, and the set of checks and the params. And so if you want to transfer in a token, you can do it here. We use safe transfer, for the USDT scenario, but in most cases you don't even need to do a safe transfer, but that's okay. And then we'll basically perform the, we're gonna set up our checks here, and we basically need that only for opening a CDP. For opening a CDP, we need to know what the count was so that we verify that something was opened. But ultimately, as you'll see down here, we just have a bunch of checks after the flash loan. We take the flash loan here, where if you specify that you want to do the flash loan, it's here. Otherwise, we're going to do handle operation, which you'll see later. But that said, we're going to do the flash loan with our ABI encoded data for operation, which is the leverage macro operation. So again, this is going to get really confusing really fast. But we're going to have our own flash loan callback. We're going to verify obviously that we called it, and we're going to verify the caller as well. And going forward, we're basically going to decode the data, and we're going to handle the operation down here. So there were two cases in which we basically, there was one case where we already went into handle operation. And as you can see, once we take the flash loan, that's really where we go. We go in this handle operation function, which will basically have a swap before here if we have them specified. And then it's going to do the callback for the specific operation type, which could be opening the CDP, closing the CDP, or adjusting. And then it's going to perform a bunch of swaps. I think if you look at these CDP callbacks down here, they should be pretty boring. Like they just perform the operation with the data provided by the caller. There's nothing special about them. and since they cannot, the initiator must be this contract, and this contract has only one access with one owner, there shouldn't be much of interest at that point. Whereas the more interesting stuff should be here in the do swaps, where we basically loop and we perform these swap checks where we don't want to grief the system, so we don't allow this. Then we have a bunch of approvals, and we actually have a completely arbitrary call, which means that you can basically reset your own approvals, you can grief yourself. There's a lot of things you can do, but you can do, it's your wallet, so that's why you can do whatever you want. And we ultimately kind of perform this operation, and then we do some swap checks at the end where you can specify that you got basically the min out that you were expecting. And so that's kind of it for how the leverage system. There's, as you can see, there's basically, after the swaps are done, you'll see that we basically have the swaps checks, and the swap checks will ultimately be just checks for the minimum outs for the amounts. So that hopefully gives you an insight into how the entire thing works. And I think I forgot something in the end of the do operation function, right? Because at this point we're in the handle operation. So the post checks allow you to have kind of these arbitrary checks where we have this do check value type, which basically has all of the operators listed and the values that come again from off chain. And so it ultimately allows to perform arbitrary checks as a way of convenience to the end user. So to make a long story short, going back, there's only one entry point. If you want some tokens, you can send them here. You're gonna do the flash loan, then you're gonna handle the operation, and then you're gonna do some final checks. And at the end, you basically sweep back to the caller so that the caller can retrieve those tokens.